the first example, 8 May. আজকে 5 10টা কোয়েশ্চেন করা পর্যন্ত। Right, take out the first question. তোমাকে আমি জিজ্ঞেস করবো, okay? So you're gonna answer. যেগুলো পারবো না ওগুলো আমি solve করে দেবো. So let's start with the first one. $5 billion. Yeah, but the buyer is the aage cheap chilo. No, it was also possible before. I don't know why people are suddenly realizing this. It was only 800K before. Yeah, and then no one took it. So why would somebody take it now? It's just I don't need it. So the thing is that they are calling it the gold card to make it sound fancy. It used to be called EV15, so it wasn't that fancy. So they just rebranded it with higher price, nothing else. And all the criminals who prefer to go to Dubai. So why would they go to US and give more taxes? No income tax, but you do have like VAT. VAT is the worst. So you already pay taxes and then you again pay taxes. It's sometimes even triple, because if you earn more, you have to pay again more taxes. So that's why you have to go to Dubai. Okay, it says number 1, the point P in figure 1.1 represents a point mass. On figure 1.1, draw lines to represent the gravitational field around point P. Right? Can you try it? What should it look like? There's a name to describe that. Radial. Okay. How many lines did you draw? 3. Yes, and then like that. Like that. It's fine. But I think this would be better. 45 degrees. But by the way, your one is not wrong, but generally the standard is to do this and then double that. Okay. Yeah, this one is more common. Not that the other one is wrong. That's fine as well. Right. What else did you do? Right. Exactly. So there's an arrow pointed towards the mass, because it's a gravitational field. Gravitational field is only what? Attractive, right? So arrows dite hobe. You need to put arrows on each line, by the way. Okay. I think somebody just drew one arrow. No, সবগুলো মধ্যে দিতে হবে. Right. So this field has a name. What would you call this field? It's called a radial field. আচ্ছা, এটা এখানে চাচ্ছে না ওরা, but description হচ্ছে it's a radial field. And can you tell me what else does this field signify? So is this field representing a uniform field or a non-uniform field? Non-uniform, right? Not only non-uniform, as you go further away from this point, how does the field strength change? Decreases or increases? Increases. Yes, further you go. Decreases. In what relationship to distance? Yes, very good. So the field strength E follows an inverse square relationship the further you go. Okay. It says the moon is in circular orbit around the planet. Explain why the path of the moon is circular. Can you try? Right. Perpendicular to the velocity and marks. Explain why the path of the moon is circular. Okay, that is fine. Right. So why is this orbit circular? By the way, when might it not be circular? মানে তোমার orbit হচ্ছে সবসময় circular হয় না. Let me clarify something, okay? So when you have your planet, let's say the Earth here, and it in a question আসার chance কম, but not impossible, okay? So you have a mass here. When you have a satellite that's right around the planet, satellite কত দূরে থাকে from a planet? Any rough estimate? How far are satellites from a planet? Very close, right? So if you think of basketball as a planet, right? It's a thread thickness away from the basketball. That's where satellites are. They're very close. Low orbit satellites bola hoy. Their orbit is almost perfect circle, but they are not perfect circle because the Earth is not a perfect circle. Doesn't need to elongate it, right? But as you go further away, you have the moon, right? It's actually quite circular. But then as you start to go further and further away, the orbits are not circular anymore. What are they? They are elliptical. এটা জিজ্ঞেস করে নাই, and I hope জিজ্ঞেস না করে, but যদি করে, why are orbits elliptical? কি আমাকে বলতে পারবা? Sorry, বলো bro. Acha, I think you're trying to say what I'm thinking. Why is it not constant? Path is not constant. But why is gravitational force not constant? No, so why not make a big circle far away? Why does it get distorted? It's a very advanced question, by the way. I don't hope close, but it wouldn't cause such a distortion. Yeah. Because the speed of the orbit is not constant. But why is it not constant? So my question is this, okay? Why are orbits not circular all the time? You guys are telling me the effect. You're not telling me the cause. Caused by the but yeah, so the sun is no, I'm saying like the Earth going around the sun, right? Why is that elliptical? No, what a problem. But it isn't. No, but that's the effect. What's the cause for it? তোমরা যা বলছো কোনো কিছু wrong বলো না. You said that velocity vary হচ্ছে, orbital length change হচ্ছে, it's not a circle, other planets exist, the sun exists. None of these are wrong. These are all correct statements. But it's not really answering the question, why is the orbit elliptical? Right. Okay. So I'm বলছি এটা আগে থেকে বলে রাখলাম, it is actually like tier level হচ্ছে complicated. জিজ্ঞেস করে নাই কোনোদিন, but I talked about it. That's why I was hoping যে কেউ পারবা. We understand the reason why most planets and objects in space have a distorted orbit. It's because they're not actually going around a fixed center. Their center of rotation is continuously changing. So turns out when the Earth goes around the center of around the sun, right? It's not going around the center of the sun. The Earth is actually going around which point? There's a point between the Earth and the sun. The center of gravity is acting. So Earth, their gravitational force is acting that way. Sun is acting that way. So the sun, what because of the Earth, wobbles. And that's actually how physicists or astrophysicists find the existence of other planets out there. So they're looking at a star and they see the star is wobbling. What can cause the star to wobble? There are planets around it. They're tugging onto the star. Okay. And here's the thing, the bigger the mass becomes, the tug becomes what? More prominent. At the point, if the sun and the planet have the same mass somehow, right? They'll form a system where both of them are going around each other. It's known as a binary system, like a binary star. I think there's a question on this in this paper. Yeah, Pluto and its moon, Tabroche, Jupiter, for example, is actually capable almost of moving the sun around. So most of the planets' orbital changes are not because of them. It's actually Jupiter's pull on the sun. So if I show you an animation, you'll notice that the sun is actually doing this. Sorry, it's actually doing that. As it does that, isn't the orbit changing? Because the center of gravity is not the same anymore. That's why the planets have this elliptical shape.
Isn't the mass of the sun like 99% of the solar system?
Mass of the sun, 99% of the solar system, yes.
Like even
It can still be distorted. So the center is not at the center. So I'll clarify your thing. It's 99% of the mass, right? But the mass is actually over a very large area. So the center of gravity can shift by a very large amount. It's shifting, but it's shifting by a large amount because the sun is very big. So that shift causes the orbital change to take place. Okay. Right. So এখানে লাগবে না, এখানে হচ্ছে the Earth is barely moving because of the moon. Okay. So explain why the path of the moon is circular. What's the answer going to be? The moon experiences a constant centripetal force exerted by the constant gravitational force provided by the Earth. As a consequence, the speed and radius remains constant, forming a circular orbit. Constant gravitational force provides a constant centripetal force. Yeah, I think so. But radius and speed needs to be constant, as we mentioned, because the formula is what? V equals to omega r. If V is constant, what must be constant? R. And if R is constant, what orbit do you have? Circular orbit, right? Right. Why is the orbit elliptical? Yes. So in addition, why are orbits of larger masses elliptical? So answer to this is because as a large mass orbits the sun, the center of rotation is a point that is moving around between the Earth and the sun. This results in an orbit that changes radius continuously, resulting in an first one. Earth is very dense. It's the most dense planet out there. So, despite its mediocre size, it has a good gravitational pull.
if you remove the gas from Jupiter, would that be this?
No, Jupiter is fully gas. It's pressurized. So the pressure of the gas on the top is causing it to solidify. So if you remove the gas on the top before we turn it to gas again, there's no solid material in Jupiter. Yeah, if you took all the gases and compressed down them to like a solid ball, it will be definitely it'll actually counter the sun because the density would be so much that the gravitational strength will increase. If it becomes the size of there was a map, it's called the Schwarzschild radius. Like how much radius do you need the mass to be so it turns into a black hole? I think for the sun it was like a marble. Yeah, so if you bring all the mass of the sun into the point of a marble, it forms a black hole instantly. Marble or melon, one of them. I forgot. Yeah, so I don't remember which one exactly, a watermelon or marble, one of them. Yeah. But yeah, at least none of which will have them. Yeah, they just make black holes for fun. Oh, হ্যাঁ, আচ্ছা, just a second, তোমরা লেখো, আমি একটা জিনিস দেখাইনি, the orbit কেন হচ্ছে change হয়েছে, so there are a couple of demonstrations here. Just disclaimer, I haven't seen a question on this yet. It's just speculation. Right, so did you play Kuri? I think this is right. So do you see this? The purple orbit is the orbit for a planet, right? But do you see that the sun at the center, is it stationary or is it moving around? It's also moving around. Can I? Because if I put the arrows here, let me zoom in. I can kill up or arrow, gravitational force. Yes. So they both have a common center towards which they're actually pointing. And a common center to center. Do you see that the center is not in the sun, not in the planet? It's somewhere in between. Orbits take place around the common center of mass. My দুইটার center of mass যে জায়গাটা common, ওই জায়গাটার মধ্যে। So এখানে center of mass common কোথায়? Little outside the planet. So আমি যদি এই প্ল্যানেটের mass বাড়াই দেই, can I do that? Let me check. Yeah. So দেখছো সেন্টারটা দূরে সরে গেছে, and now do you see the orbit goes into it's called a dead spiral. So at the point they may collide into each other. It's a very complex math. এই জিনিসটা হচ্ছে এখন হচ্ছে সিমুলেশন ছাড়া ফিজিক্সে করতে কষ্ট হয়. So turns out the mass I've chosen actually has set it into a simple harmonic motion. So it will continue to do this. Okay, এখন আমি mass বাড়াই দেই, সেম করে দেই, it has now formed a binary system because their center of masses are exactly at the center. So they're both orbiting, but they're orbiting this imaginary central point out there, and that's how binary system forms. Okay. Of course, but if you add one more mass, there's no math, and it's one of the mysteries in science. It's called a three-body system. So if I add one more mass here, and now you want to predict where will they go, it's like a toss of a coin or a die, random. There's no predictable path. It is the three-body problem. What is the sun? The center of our Milky Way. The supermassive black holes. So sun was orbiting the center of the Milky Way. It is binary systems also form between black holes, but they yes, binary systems. That's actually a good question. Binary systems can form between black holes, but they collapse and they collide. Neutron stars as well. It's because their mass evaporates. Black holes are in the and at the point where they vaporize. Before that, there's a point where they don't have enough gravity to keep themselves in orbit, so they collapse upon each other. Once they are not fed enough masses, they start to vaporize. The energy is lost. Hawking radiation, call it. Oh, it's given off as radiation. So there was a theory by Stephen Hawking that black holes vaporize by giving off this radiation called the Hawking radiation. No, we have some proof. When black holes do get bigger and smaller in size, so there must be something being lost. Yeah, because time becomes not linear, stagnant. So you can see the entirety of time, but you won't have that, consciousness to do that, because once you're in a black hole, there's no oxygen. You're not alive. But yes, if you were alive, you scroll through like a timeline and see what's going on because it's static. Yeah, something like that. Acha, let's move on. What are you guys doing? Acha, so see, many moons are in circular orbit around the planet. The angular velocity of the moon is omega. When the orbit of the moon has a radius of r, this is the equation out there. This is basically the graph for Kepler's equation, that T square r cube. And I will show that the mass m of the planet is given by the expression gradient by g. Printed. Oh, I thought that maybe that's what we need to find. I mean, to take it. 1 by omega square. But can I print as another? Oh, there is actually 1 by omega square here. It like there's a lot of things missing here. This is it. The x-axis. The x-axis. Right, so the mass of the planet is given by this expression. So it's a moon whose angular velocity is omega and radius is r. What was that formula that related these things? G. Right, exactly. 2 marks, we can just directly go for G m by r square equals to m omega square r. So you can take out G m cancels out. G m equals to omega square r cube, or a y-axis is such r cube, our x-axis is 1 by omega square. So r cube is equal to 1 by omega square times gm. Or কি বের করতে বলছে, show that the mass, আচ্ছা বুঝছি. So gradient এখানে কি হবে? Gradient, so this is going to be equated to which equation? Y equals to mx, and y is my r cube, m is going to be gm, and x is going to be what? 1 by omega square. So therefore, but gradient by g as show there. Oh, sorry, yeah, yes. So gradient here would be how much? gm. Amar darkar konta? M. So m equals to what? Gradient by g. 2 marks এর জন্য এত কিছু মেবি করতে হবে না, আমি তাও একটু চেক করে দেখি কোনো কিছু কি শর্টকাট করছে নাকি ওরা. Oh, they did all of this. Oh, surprisingly they did all of them. Mark distribution তাহলে কি একটু বলি. Mark distribution হচ্ছে এইটা লেখার জন্য 1 mark, and the entirety of this is 1 mark. মানে showing it as a straight line, that's another mark. Okay, so these are the 2 marks out there. Clear about this? আচ্ছা, এখানে বলছে figure 1.2 and the expression ci shows expression in ci to show that the mass of the planet is given like that. So এটা আমরা কি করব? First we need to find the what from this, the gradient. Gradient টা কেমনে বের করবা? I think this is easy কারণ এটা 4.1 I think, right? 4.1 মানে আমরা পুরো ট্রায়াঙ্গেলটা নিতে পারবো, আর নিচেটা হচ্ছে 6. So gradient is 4.1 into, careful, এখানে অনেক কিছু আছে, 10 to the power 23 divided by 6 into 6 না খালি 6 into 10 to the power 7. That's the gradient, but the gradient gives you what? gm. So g is 6.67 into 10 to the power minus 11 into mass of whatever we are trying to find equals to this gradient that you have here. সব করলে কত আসে কি বলতে পারবে একটু massটা? 1 into 10 to the power 26 kilogram. Determine the speed. I always get confused about getting value from a graph. In the y-axis, the label says 10 to the 23. Why do we multiply instead of divide it? Good question. So, can we multiply instead of divide it? So basically, this value here is how much? So আমাদের একটা rule আছে, and by the way, we are unfortunate. I found this problem with a syllabus students Excel and Cambridge দুজনেরই graph plot করার যে fundamentals টা ওটা শেখানো হয় না। যে graph যখন plot করা হয়, you have to plot what on the graph, not quantities. values that are unitless. So our value is actually what? 4 into 10 to the power 23 meter cube. You cannot plot a quantity of meter cube on a graph. You can only plot the watt, the magnitude. So first we need to remove the watt from here, the unit. How can I remove the unit here? By dividing this number by watt, 10 to the power 23 into meter cube. Once I divide these, right, cancel out. What do I have left? 4. That's what you put on a graph. Sometimes the graph has a quantity that's lost this unit. Now, if you want to get it back, will I divide or will I multiply? Because I'm divided by baad dilam na. So if I want to get back my original value, right, don't I need to bring it back? So কি করতে হয়? Multiply করতে হয়। এটা কোথায় প্রবলেমটা হয় আমি বুঝছি। এটা অনেকের যে পেপার 5 এ গ্রাফটা থাকে না, সেকেন্ড পার্টটাতে ওরা তখন ওরা ইউনিটগুলোকে আনতে বলে। দেখবা যে বলে যে find the gradient and write its unit. Tখন students don't know, do I multiply or do I divide? Always remember, to plot a graph you have to divide and get rid of stuff. That's why the symbol is actually a division. It is a division symbol এখানে, right? But to bring things back in, what do you need to do? Multiply. So just multiply the values. Determine the speed of the moon in orbit around the planet and with orbital radius that speed বের করতে বলছে। So কেমনে বের করব আমরা? V equals to root gm by r. How do you get that? Achha. Okay, so gmm by r square equals to mv square by r. Yes, so gmm by r square equals to mv square by r. A velocity যেটা এখানে দেখতেছে is the actual speed of the moon, right? So এটা cancel out হয়ে যায়, a mass টা cancel out হয়ে যায়, so v equals to root gm divided by r. এটা যদি ওরা হচ্ছে by default দিয়ে থাকে, তাহলে আমি তোমাদের যেটা করব is লিস্টে দিয়ে দিব, otherwise লিস্টে দিব না। দাঁড়াও, oh no, they derived it, so you have to derive it. So এখান থেকে হচ্ছে g is how much? 6.67 into 10 to the power minus 11 into what's the mass here? Mass of the whatever we found divided by, was it the mass of the planet or moon? Planet, yes, and divided by r, 1.2 into 10 to the power 8 root over কত আসে? Yeah, exact calculator key that বলবো because I want to teach you the significant figure thing. Right, that's what the value should be, right? But when you write your answer here, you need to write your answer based on the significance of the data provided. If you look at the data given here, this one is how much? 2 significant figure, 2 significant figure, mostly 2 significant figure থাকার কথা সব জায়গায়. Your final answer has to be then how much? 2 significant figures. So what should it be? 7500. And you'll see that marks mechanically এটাই লেখা ওরা. And I have no evidence যে ওরা কি mark কাটবে নাকি if you don't do it, but I think it's better to be safe. That তোমরা at least দেখবা যে marks এর সাথে answer সব match হচ্ছে. Okay, significant figureটা maintain করবা. Is that clear, this question? So in terms of difficulty, I would rate this question as medium. Easy, it's easy, but it's a medium because it's not the traditional question we get. So তোমাদেরকে বলে রাখুন যে কোনটা কি লেভেলের হয়। Let's look at this one. State the Newton's law of gravitation. Right, this one. So Newton's law of gravitation. As far as I remember, it took like 2 marks. Right. The Newton's law of gravitation states that the force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to the square of their distance separation. I'm just acting to confirm or a key point mass mandatory course. Some years they do, some years they don't. No, bracket. What does that mean? Optional. Okay, so it's not mandatory. But to the underline for that, it must be there in exactly the same way. Okay. Right. Again, a graph. Seems like it's the same type of question, right? That's a query. The planets are observed orbiting a star in a solar system. The measurements are made of the orbital radius r and the time period t of each of the planets. The relationship is given here. Determine the mass. So, the mass will go to 3 marks. So, I'm going to first figure out a graph key versus key, t square versus r cube. So if you have a graph of t squared divided by r cubed, the gradient of the graph will give you a lot. 4 pi square divided by gm. And what are we supposed to find? M, right? The long graph the gradient. Thankfully, the numbers are straightforward. This is 2.4, or it's also 1.2. So 2.4 divided by 1.2, and it also 10 to the power 34. But উপরে একটা problem করছে তারা। উপরে 2.4 কি দিছে এখানে? Year squared, right? What do we do here? Right. So আমাকে 2.4 year কে second তে convert করতে হবে. How do you do that? Into 365 into 24 into 3,600, and then what do you do here? Square it there. Do you square the 2.4 or do you square only the conversion? Conversion, right? Because 2.4 to the value. So square. Check korba eta equals to ki hobe 4 pi square. So 4 pi square divided by gm, 6.67 into 10 to the power minus 11 times m. Therefore m koto ashe? 3 into 10 to the power 30. Is that the sun? Acha, okay. Yes. Yes. The rock of mass, okay, this is important. The rock of mass m is also in orbit around the star. The radius is r. Explain why the gravitational potential energy of the rock is negative. This is that 3-mark generic question. Can answer for what? Yes.
Gravitational field on the attraction to go further away from black mass and it must be applied / loss to move object gets
One point is correct. It's attractive. There has to be another point. Okay, so a couple of points were right. You said first you said that the attractive force, right? That's correct. You didn't say the infinity is 0. That's the other point.
Also, another point I said was energy supply
to move it away.
Yeah.
No, in that case, it will be gained, right? If you give energy to a system, it gains energy. So when you have a rock, right, and you let go of it, it says it's moving. Why is it negative? So as you come from infinite and towards the planet, right, are you gaining energy or losing energy? Losing. And that's why at any given point, you're continuously losing energy. So negative signifies the fact that there's always a loss of energy as you move towards the planet. I think you said then it'll gain. So if you go the other way, it's a gain. But our equation is when a mass is brought from infinity to a point within the field. Okay. So I'm like a generic question. I'll give you the version. I'll add it at the top as well. So right. So question why is gravitational potential energy negative? I'm points in it so that you know kemne likhte hoy, but exam pura paragraph. Okay, so first point hocche the potential is considered to be 0 at infinity. Second point hocche as the mass moves into the field from infinity, it loses gravitational potential energy as work is done by the mass. The mass is doing the work, right? Lastly, the mass.
It's a fair.
Oh, right. Sorry, you're right. That's what I was wondering.
Second, gravitational force never be 0.
No, there's no mass. then it's like very small, but mathematically if you go to infinite it's zero, so it's like really far away. No, that's the reason why universe exists, because that small amount of force was necessary to bring all the masses in to form stars in the first place. Yeah, but it's not going to be zero. Right, so these are the 3 points that you need to have. Which one? Third one? Yeah, as a mass moves into the field from infinite, it loses potential energy. So your mass is at infinite, and you release it. Which way does it go? Down, right? So as it's moving down, is it gaining more energy or losing the energy it has? So how do you signify loss in gravitational potential energy? The plus or a minus? That's the minus. Yeah, so the mass, so when you do work on the mass, it gains it. When work is done by the mass, it loses it. The other way around. That is true, but it doesn't imply the negative nature of it. The Mars में देखो कि flex में कि sometimes they write that point. The work is done to move it to infinite. Lectable, you can write that. I'll just show that the kinetic energy of the rock is given by this formula. How do you find this? Half mv square. আচ্ছা এটা একটু দেখে তোমাদেরকে সবাই স্ক্রিনে দেখো কেমনে করতে হয়. So how do you find the kinetic energy of the rock? So you should basically write the fact that Ke plus Gp must be equal to what at any given point? 0. তার জন্য তোমার Ke যদি gain হয় Gp loss হবে, এটা উল্টো দিকে নেগেটিভ হয়ে যাচ্ছে না? So their values are always going to be what to each other, opposite. Do you understand that? তারপর you can say that হচ্ছে Gp is negative because we are assuming it's to be been lost, right? So if it's negative here, if you take it to the other side, you can write K equals to Gp. K is going to be half mv square. Gp কি হবে? G m by r. R নাকি r square? R. না, gmm by r square তো হচ্ছে তোমার right. So এটা ক্যান্সেল আউট হয়ে যায়. এখান থেকে কি হচ্ছে v square equals to আমার কি যাচ্ছে কাইনেটিক এনার্জি যাচ্ছে খালি. আচ্ছা সরি এটা ক্যান্সেল করার দরকার নাই. তাহলে হচ্ছে gmm by I think ওটা বেটার হবে. যেটা একটু আগে আমরা ডিরাইভ করতাম কি ছিল gm by yeah, so v square equals to root gm by all right. So ek is equal to half m. Yeah, I think this is a better path. Half m is m. V square is going to be gm by r square or r. So এখান থেকে আসছে হচ্ছে gmm by 2r. Is that what it is? ঠিক আছে. I use the expressions in C to derive an expression for the total energy of the rock. Yeah, this was the one I was referring to. So C2 থেকে use করে total energy of the rock বের করতে হবে. So how do you find the total energy of the rock? So let's say the rock is at a given point here, randomly around the mass. At that point, it has a K, and it also has what at that position? Gravitational potential, phi m, right? So what's the total energy going to be here? Yeah, the addition of them, right? So it's going to be the K it possesses plus the gravitational potential energy. The K is going to be what? Gmm by 2r. And what's going to be the potential here? Minus, so phi into m. phi into m. Phi হচ্ছে gm by r into m. So এটা যদি আমরা করি, we get gmm by 2r minus gmm by r, which is basically minus half of it, right? Minus gmm by r. আমি এই সেটা বুঝাই, ওকে? এটাই আসলে এক্সপ্রেশন, দাঁড়ান চেক করে দেখি। হ্যাঁ, 2r মানে half, right? So let me clarify, যারা বুঝে না জিনিসটা, look at this. You have a mass here, and this is the sun or whatever the star is, right? And there's a point here which is your infinite. That's the point, right? Infinitely far away. Now you have the mass coming from here into the field here. At any given point, there are two energies it possesses. If it's stationary, it has only one energy. What is that? Potential energy. But it's moving, so it's kinetic energy as well, right? So energy total, right? So total is going to be equal to the k at that location plus the what? Gravitational potential energy. একটা জিনিস মনে রাখো, GP এর কোনো formula আমাদের syllabus কিন্তু officially নাই. Our syllabus only follows the formula of what? Change in phi into m. Okay, so the k here would be যেটা আমরা বের করছি gmm by 2r, and the GP at that point is going to be phi, which is minus সবসময় minus হবে, একটু আগে তো বলে আসছে, so this has to be minus gm divided by কি হবে r into what? M, because GP, if anyone doesn't know this yet, is phi into m, right? So এটা করার পরে তুমি সিম্পলিফাই করলে পাবা minus gmm by 2r. That's the total energy at any given point. Yeah. That's a big mix up. Like 15 minutes আগে ছিলাম এখানে। আচ্ছা, let's go to May June 21 এরপরেরটা। Okay, it says that the Earth may be assumed to be an isolated uniform sphere, and the mass of 6 into 10 to the power 24 kilogram concentrated at the center. So that's the information provided here. Satellite of this is given here. Define gravitational field strength. What is gravitational field strength? Yeah, it's the force exerted per unit mass, gravitational field strength, this one. So our bolichi, if you can at least remember your definitions, it's like easily a grade or two, just definitions. Oh, you get that? Depends on the paper. I've said this before, and then there's a paper with only 10 marks of definition, so that means you get nothing, right? But there's a paper with 31 marks of definition. So 31 marks of definition মানে হচ্ছে ওই পেপারে A ছিল 67, so half the paper is like you can get an A with just like 50% definition, and then you have to just do some 30 marks of math out there, which is like 3 marks in every question. Acha, so calculate the radius of the orbit of the satellite. 3 marks provide করতেছে, radius বলছে, এখানে time period দেওয়া আছে। এটা কি হবে? So আমি তোমাকে বলে দেই, you should know this by now. Whenever there's time provided and it's an orbit, there's only one equation in your syllabus. T square equals to 4 pi square by gm r cube. আচ্ছা, আর কোনো কিছু করতে হবে না। Now the problem is that in some papers I have seen they were derived করে দেখাতে বলে এটাকে। Some papers they can directly just jump into it. They are not very clear about this. I personally feel that it's start for just to be safe, centripetal force equals to gravitational force, and then maybe write that equation. Okay, so you'll write gmm by r square is equal to what? M omega square r, and then yes, you can probably directly go to interesting.
The frequency of these errors is increased.
What frequency?
Of the errors. Stick to one thing.
Both rows. All right, so what should this equation be? The simplified version. T square is equal to what? 4 pi square by gm তারপর r cube. আমাদেরকে বলছি কি করতে হবে এখানে? We need to find out the radius. So time হচ্ছে 94 minutes. এটাকে seconds এ convert করতে হবে. So 94 into 60 squared. Square গুলো ভুলো না, তোমাদের প্রায় দেখি square problem হয়. Divided by gm 6.67 into 10 to the power minus 11 into mass of this. Should it be 1200 or should it be 600 in the power 24? Yes, always remember that the mass that's involved here is not the mass of the object, but the mass of the thing that around which it orbits, right? Pi square into r cube. So bolo koto ashar? 6.1 into 10 to the power 6 meter. 6.9 into 10 to the power 6. Okay, next বলছে that এটা একটু দেখো, these are important questions. Rockets on satellites are fired, so the satellite enters a different circular orbit and has a time period of 50 minutes or 150 minutes. The change in mass of the satellite may be assumed to be negligible. Show that the radius of the new orbit is 9.4 into 10 to the power 6 meter. এটা করার দুটো way আছে. One is a very long way, one is a way they want. 2 marks যেহেতু, you're supposed to use ratio. কেমনে ratio use করবা? We know that t square is proportional to what? R cube. So প্রথমে ছিল 94 minutes and ওইটার জন্য radius কি আসছিল আমাদের? 6.9 into 10 to the power 6. So 6.9 into 10 to the power 6 meters. And এখন কত বলছে time? 150. So what should the radius be is what we need to find out. But the risk with ratio here is that some students don't understand যে এখানে কিছু আরো করতে হবে। কি করতে হবে? আমাকে t square যেটা, এটাকে square করতে হবে, এটাকে square করতে হবে, এটাকে কি করতে হবে? Cube করতে হবে, এটা cube হবে, direct proportion. তাহলে তোমার r cube is going to be equal to what? 6.9 into 10 to the power 6 cubed into 150 square. Do you need to break it down into seconds? No, because ratio, so it will actually have no overall net impact. 94 squared. এগুলা করলে যেটা আসে, that's your answer. কেউ চেক করবা কত? Of course, there's going to be a larger radius. Let me check there. 9.4. 8.4. Completely different. Did you cube root it? Yes, squares and cubes. Nine 9.4 into 10 to the power 6. Yeah. It's fine. So what you'll do is you'll have to find the equation again with 150 as the value.
For my equation, I actually got 7.1 times 10 to the power 5. And I still got 9.4 times 10 to the power 6.
How do you get 7.1 here?
For some reason, my 3C1 is still correct.
Acha, I understand why. Did you use ratio for this part? Formula. Interesting.
So it doesn't matter what your difference is because if you don't use the ratio.
Oh, yeah, that's true. You didn't use the ratio, right? Yeah, if you don't use the ratio, then this number is not needed, right? State with a reason whether gravitational potential energy of the satellite increases or decreases. Important question. If you go higher, increases, right? Because you're going further away. ওরা কিন্তু বলছে state with a reason. So reason কি হবে? আচ্ছা, আমি একটা ওয়ে বলে দিই লেখার জন্য, এটা একটু আগে মেনশন করেছিলাম। As you're moving away from the mass, you're doing work on the mass, so it gains it. It doesn't naturally go down, right? Don't you need to pull it up, right? So you'll say it increases. It increases since work needs to be done on the system to move it upwards. Minus phi equals to minus gm by r. Phi decreases. Very good. You understand that. If you understand that, you can use it. Okay. আমি একটা জিনিস একটু clarify করি সবাই দেখো এদিকে। It's a problem that you will face. There are a lot of questions where this happens. Problemটা হচ্ছে phi is equal to what? Minus g m by r. এখন some students will want to use the equation to explain this, which is actually a very good thing because the equation used for explain is a very good practice. But as you're going further away from your mass, radius কি হচ্ছে বেড়ে যাচ্ছে না? So radius যদি বেড়ে যায়, that তুমি নোটিস করবে এখানে phi ভ্যালু কি হচ্ছে? কমে যাচ্ছে। But shouldn't gravitational potential energy increase? Then how does that work? Yeah, so the negative sign basically means that actually বাড়তেছে because you are going from a smaller negative value, like you're from a higher negative value, let's say minus 100, to a smaller negative value. Wouldn't that mean a gain in energy or gain in value? So keep this in mind when you do this math. যেখানে যদি আমার minus phi-টা বেড়ে যায়, তার মানে phi-টা actually কমে যাচ্ছে because the minus inverses that relationship. Okay, next বলছে determine the magnitude of the change of gravitational potential energy of the satellite. Right, এটা করার জন্য হচ্ছে it's that question. Do you understand which question? Phi বের করতে হবে একটা দুইটা মাইনাস করতে হবে ডিফারেন্স বের করতে হবে ইনটু কি দিয়ে মাল্টিপ্লাই করতে হবে mass দিয়ে. It's the same every time, okay? Sometimes it's 3 marks, sometimes it's 4 marks. এখানে 4 marks দেন না কারণ তোমরা অলরেডি কাজ করে আসছো. You already found the distance and everything. So look at this, কেমনে করতে হয়? Our satellite, what's at that location, we'll call it phi 1. It goes to this location, let's call it phi 2. Phi 1 is going to be minus gm by r. And phi 2 is going to be minus gm by r2. এখন আমাকে change in phi বের করতে হবে. So to find change in phi, কোনটা মাইনাস কোনটা করবা? বড়টা কোনটা? Do you do with sign or without sign? Bigger one and right. So you could do like gm by r2 minus gm by r1 আর ব্র্যাকেটে কি হবে minus, ঠিক আছে এটা r2 is the higher value, so phi is the smaller value. No, sorry, ulta হবে. By the way, I'll tell you it doesn't really matter because what did I tell you to do? Find the net difference, right? I think it's safer. So if I do this here, what do I get here? Minus g 6.67 into 10 to the power minus 11 into m কত ছিল, the mass of the planet. It's no, it is 6.0 into 10 to the power 24 into ব্র্যাকেটের মধ্যে তোমরা এই জিনিসটা করতে পারো, মানে just to simplify it, because I think marks me এভাবে করার অনেক সময়. Okay, so what's r1 going to be? 6.9 into 10 to the power 6 ছিল minus 1 divided by পরেরটা কত আসছিল 9.4 into 10 to the power 6, 9.4 into 10 to the power 6 and close the bracket. এটা দিবে তোমার change in phi. Now তোরা বলছে change in potential energy, so change in GPE is equal to what? Change in phi into m. So এটা যেটা আসবে ওটাকে আমরা কি দিয়ে মাল্টিপ্লাই করব? 1200, right? So কত আসে? 1.9 into 10 to the power check করে দেখি ওরা কি করছে এখানে yeah so they ignored the sign bracketed রাখছে which means no significance was given to it which is the case আপনি absolute value নিয়ে কাজ করতে হবে না না তুমি মডুলাস করবা মানে যা চেঞ্জ আসে a minus b b minus a সেম চেঞ্জ আসবে so math shouldn't be a problem আচ্ছা এখানে this question is important এটা করবো এখন আমরা আমি বলিনি কোনটা গ্রাফের যে ক্লাস ওগুলাতে একটু যাবো so I think আচ্ছা because দেখে মনে হচ্ছে এই question number 4 is very similar to what we did because এই May June 21 42 না সেম ইয়ার গুলোতে ভেরিয়েন্ট গুলোর কোয়েশ্চেন গুলো সিমিলার টাইপের থাকে সো এটা করলাম না বাট যদি প্রবলেম হয় আমাকে বলো ওকে which one 5 or 4 4 b কোনটা actually আমাকে বলো will do the question which part b yeah and your problem was in part 3
So I tried to equate this together and I tried to find this, but the value of this is different from the value of this. Why is it that?
why do you want to equate this
Oh, wait, it's gravitational field strength.
yeah you're doing
Oh,
force all right so next one is gravitational field strength হচ্ছে বের করতে হবে so এখানে কি কি বলছে we know radius we know mass so gravitational field strength হচ্ছে gm by r square that's g right so g হচ্ছে 6.67 into 10 to the power minus 11 into mass is 6.42 into 10 to the power 23 divided by radius হচ্ছে 3.39 into 10 to the power 6 squared. Once you put them here, you'll get your value. How much is it? 3.73. All of the information is given to 3 significant figures, so we'll keep it to 3 significant figures. তারপর বলছে centripetal acceleration বের করতে হবে. How do you find centripetal acceleration? Yeah, A equals to omega square R. Omega হচ্ছে time period of 24.6 hours, right? So omega is 2 pi by 24.6 into 10 to the power, into 3600 square into radius is how much? 3.39 into 10 to the power 6. So the correlated should answer. How much is it? 0.017 meter per second square. V square bar? V to জানি না আমরা 0.17. Force per unit mass exerted on the object by the surface of the planet. Oh, right. So force per unit mass, weight. What's the formula for weight? W equals to mg, right? But এখানে বলছে force per unit mass exerted by the object on the surface of the planet. Surface of the planet কি আমরা বের করছিলাম এটা? মানে answer কি 3.73 না? Wait, 3.71. Actually, I don't have this paper out, but I'm check for this because the rule is this, okay? No, it says weight per unit mass. Let's try to figure out this. It's one mark. It shouldn't be complicated. So W equals to mg mass per unit mass. Unit mass মানে কি mean করে 1 kg mass and g কত আসে for this planet 3.73. তাহলে the force or weight per unit mass is supposed to be 73 Newton per kilogram, right? Same হওয়ার কথা তো। তাও আমি চেক করে দেখি এটা কি ইয়ার 2042 3 4 Oh, hey, it's not the answer. You're right. No, they did something very complicated here, but why are they doing that? On the surface? Yeah, it's for 1 mark. I know what they did here, but এটা তো এখানে কিছু বলে নাই. Oh, acha, makes sense. It's I think no one will probably get this in the exam. এখানে হচ্ছে কি বলছে দেখো, for an object resting on the surface of the planet at the what? At the equator. এটা কি ছিল তোমাদের আমি বলি, এটা quick reminder of circular motion and we learned something. Yes. So if you're on a balance or on a weighing machine on the surface of the equator, right? The force you experience is not the weight. Yeah, exactly. So the reaction force here is R. এটা একদম শুরুর দিকে আমরা পড়ছিলাম, if you remember, and this is W. And your centripetal force is the force that's acting towards the center, right? F. Can you give me a relationship for centripetal force in terms of W and R? No, Fc equals to centripetal force will always act in the direction where there's a resultant force, right? If this object is going in a circle, right, which one has to be bigger, W or R? W minus R, right? So W minus R. And আমার এখানে হচ্ছে আমাদের weight যেটা দেখি আমরা, right? ওটা কোনটা থাকে? The reaction force. So R is equal to what? F minus W. So centripetal force, there R equals to W minus F, sorry. W minus F. So W টা কত 3.73 and centripetal force কত 0.017. দেখো এটা কত আসছে? হ্যাঁ, into 1 kg. We're doing for 1 kg mass. তাহলে আমি বুঝবো যে ওরা এটাই করছে। কত আসে 0.3.71. Acha, very strange because this is on its own like a 3-mark question, and it's there in your book, which is the person standing on a weighing machine on the equator, right? Or randomly এখানে provide করছে. I do believe যে they're right, কারণ ওরা কিছু রকম করে না. We just ignored which point. It was on the equator, right? Also, আরেকটা জিনিস which I feel was unfair here is that এই রিডিংটা কোথায় আসবে এটা বলা দরকার ছিল, কারণ you'll only see 3.71 কোথায়? On the equator, on a weighing machine that shows the reaction. Because when you stand on a weighing machine, does it show you your weight? No, what does it show? Reaction, right? So reaction to কমে যাচ্ছে. Okay, yeah, interesting question. এটা আমি মার্ক করে রাখলাম, is one of those questions যেটা তোমরা next time যখন রিভিউ করবে আরেকবার দেখে নিও. Only equator, because as you go to the pole, the centripetal force is only the not zero, because you are not going around the planet, you're on the point of rotation. F equals to ma, mass 1, acceleration হচ্ছে 0.017. হ্যাঁ, circular motion করবো এটা. Yeah, one is at the top, one is at the bottom. At the top it's minus, at the bottom is plus. No, here and there, and these are the same. Acha, just before I move on, 5 you gonna question us, do you have any problem in 5? Which one? B2. Show that x is approximately that distance. Oita. Okay, it says Earth E and the Moon M, both are considered to be isolated masses and everything is provided here. Explain how it's possible for the gravitational field strength to be 0 despite the presence of 2 large masses nearby. What's the answer? The gravitational field at a point is equal and opposite, so therefore there is no net field strength at that location. That's why it's a null region. Show that x is approximately 3.5 into 10 to the power 8. No, yeah. Opposite field at same location, equal and opposite. That's a 0. No, Planck's book. Yeah, so the answer should be along this line. Field strength can be 0 given that at that particular point the field strengths are equal and opposite in direction, resulting in a net field strength of 0. Okay, next বলছে show that x is approximately 3.5 into 10 to the power 8. এটা পারো নাই? It's a class করছিলাম আমরা। কেমনে করতে হবে এটা? What do you do here? বলছে যে p is the point where your field strength is what? এই যে এখানে বলছে হচ্ছে distance provide করা and isolated masses, তারপর হচ্ছে what else is given here? Earth and Moon separated by this. Show that x is approximately that. No, but p কি null point বলছে কোথায়? No, but আচ্ছা No, I know that, but they have to mention this null point, right? এখানে কিছু বাদ পড়ছে আমি কোশ্চেন পেপারে দেখি। That's an assumption. Yes, এটা actually বাদ পড়ে গেছিল। We can't just assume that for our convenience. Oh yes, it must be a null point. No, if you want to assume things, why not just assume that p's value is something that you have guessed? P is a point on a line joining the centers of E and M where the resultant gravitational field strength is 0. Okay, that was that statement there. Yeah, now what do you do here? So gravitational field strength of Earth should be equal to what? Gravitational field strength of Moon. That was a shortcut that I derived, remember? The ratio of the distance is actually the ratio of the root of their masses. ওটা চাইলে ইউজ করতে পারো, but দরকার নাই, এটা gm of Earth divided by distance of Earth square equals to gm of Moon divided by distance of Moon squared. G cancels out, mass of Earth, mass of Moon, distance বসাবা, answer চলে আসবে। কত আসে? শো করতে হচ্ছে তো, right? Distance of Earth মানে হচ্ছে Earth থেকে এই পয়েন্টে কতটুকু distance, how much is that? X. And Moon থেকে এই পয়েন্টের distance কত? That whole distance minus X. And solve it for X. Wait, math পারতেছ না মানে এটার ম্যাথটা পারতেছ না? You got that much, but you didn't get the math. আচ্ছা করে দিচ্ছি. I thought you didn't get the idea here. It's a 5.98 into 10 to the power 24 divided by distance হচ্ছে x square equals to mass of moon হচ্ছে 7.35 into 10 to the power 22 divided by পুরো distance কত 3.84 into 10 to the power 8 3.84 into 10 to the power 8 minus x squared. এটা কেমনে সলভ করতে হবে? আচ্ছা কেমনে সলভ করবা? Yes. Okay. So what you do is you take this to the top and you take this to the bottom and you place this here, and then what do you do? Root, right? So you root both sides, and as you root both sides, তাহলে হচ্ছে a square চলে যাবে, and then you didn't do it this way? Oh my goodness. আচ্ছা, okay. Right, so once you do this, you solve for x. আর তো কিছু করার নাই এখানে. Quadratic like minus b plus minus, so it. Oh my god. For like 10 years of math ends with this, that you have to resort to quadratic equation for this. Binomial equation থেকে লগলা. আচ্ছা, anyways, ব্যাপার না. Answer আসছে? আচ্ছা, by the way, এটা কিন্তু রুট করার পর একটা প্রবলেম হয়. Yeah, plus minus হয়. আচ্ছা, এখানে লাগতেছে না, but just letting you know because there are two values possible. Okay. Yes, because null point is when it's zero, but in let's say this is a random mass, there's a question coming up now where that point is not at the null point. You have to find the gravitational force at that place. Phi কোনো problem ছিল এটা? Phi? State the relationship between gravitational potential and gravitational field strength. আচ্ছা, এটা একটু ইন্টারেস্টিং, এটা আমরা ওইখানে যাই করবো. সবাই একটু দেখো, state the relationship between gravitational field strength and gravitational potential. এটা হচ্ছে gradient of negative gradient of this graph. আমি তারপর বুঝাচ্ছি কেন এটা, because it's something that you need to be aware of. এরকম আরেকটা আছে কোয়েশ্চেন, জানো কোনটা? Exactly same. Yeah, what is the definition of electric potential in terms of electric field strength? Okay, so let's start the graphs. আজকে একটা কোয়েশ্চেনই পেলাম আমরা গ্রাফের. So the graphs from gravitational field. The first one here is the graph for potential. How does the graph for gravitational potential look like? So y-axis হচ্ছে phi and x-axis হচ্ছে distance. So this is phi. Phi হচ্ছে joule per kilogram, and এটার distance হচ্ছে d in meter. And right, tell me, how does the graph look like? Yeah, so it's basically, it's called the gravitational well. It looks like a well. আর এটা সুবিধাটা কি, এটা কোনো ভেরিয়েশন নাই, সব গ্রাফ ফিল্ডের জন্য এরকমই দেখতে হয়. Electric field গেলে it becomes a bit of a problem because electric field there are 4 different combinations out there. They have mass নাকি plus নাকি minus and whatnot. আর গ্রাফটা কিন্তু হচ্ছে symmetrical on both sides. এখানে what is the assumption made here? Point mass, right? So we're going very close to the center of the mass, but we'll never reach it. But in reality, at a point again, we stop. Where do we stop? Yeah, radius of the planet. So radius of the planet is the furthest you can go. So graph to পর্যন্তই থাকবে. Okay, so yeah, this is how the graph looks like for gravitational potential. Yeah, right. And you can see all the values are what? Negative, right? So values can show negative দেখাচ্ছে এখানে. Now here's the thing. Questionটা কি বলছে? What is the relationship between gravitational questionটা কি একটু repeat করবা? What's the relationship between gravitational potential and field strength? Right. So যেটা করব আমরা এখানে একটা small derivation. So derivationটা দেখো, gradient of this graph কি দেয়? So gradient of this graph is going to be change in y by change in x. Y-axis is what? Phi, and by change in phi, and x-axis is what? Change in distance, right? Now, আমরা এখানে যদি ইকুয়েশনটাকে ব্রেক ডাউন করি, this is going to be minus gm by d divided by what? D. What do you get here? Minus gm by d squared. What is that equation for? Yeah, it's gravitational field strength equation, but there's a what sign here? Negative, right? So therefore, the gravitational field strength G is what the gradient of this graph? Negative gradient of a what graph? Phi versus D graph. Does that make sense? Okay. So আমি তাও চেক করে দেখি ওদের ওয়ার্ডিংটা কি, ওরা usually একটা statement লেখে, like this equal to minus that, but sometimes they'll describe এখানে কি করছে দেখি. This is question. Oh, it's just that. It says gravitational field strength equals to the gravitational potential gradient, and the second mark is minus gradient. Okay, so that's what you write. So I'll write it for you guys. Say the relationship between gravitational potential and gravitational field strength. Gravitational potential or gravitational field strength. Gravitational field strength is the negative gradient of আচ্ছা এটা করি আমরা, এটা করে will be done. Okay, a moon of mass m and radius r orbits planet 3m and 2r, radius of 2r at a particular time and everything. So এখানে কি বলছে, এটার mass হচ্ছে 3m আর radius হচ্ছে 2r, আর এটার mass হচ্ছে m and radius হচ্ছে r. The distance between the center is d as shown in figure 2.1. Okay, point P is a point along the line between the center. So point P হচ্ছে এই মাঝখানে একটা central point with a variable distance x. Oral bolche the variation of x with gravitational potential is given here between the two masses as shown here. Explain why phi is negative throughout the entire range from 2r to d minus r. 2r, so 2r to d minus r. মানে যে এই পুরো জায়গাটা পর্যন্ত. So why is it negative throughout? কি হবে? How do you answer this? It is actually the same answer as which one? Gravitational potential at the negative value ta oja. Okay, because throughout this process, the force acting on the mass is what? Attractive. It is towards the center, and we are considering the furthest point here to be what? Infinite, right? So same answer আসবে. দাঁড়াও, কোথায় গেল? আচ্ছা ওটা আমরা পরে লিখতেছি। আর বলছে এখানে আমি এখানে জাস্ট অ্যাড করে রাখলাম same as y phi is negative. Mental marks can check with anything additional add course. One of the features of 2.2 is that the phi is negative throughout. Yes, describe two other features here. Key and like other feature. Right, the potentials are different at the surface. That's one thing. 0.9. Sorry. Gravitational field strength is 0 at the maximum point. Why? Very good, right? একটু আগে আমরা বলে আসছি না, gradient of this graph gives us field strength. You can actually define those. So you can say that the field strength near the surfaces are what? High, right? And you can also say that the field strength at that point is what? 0, right? Also, you can say that the highest gravitational potential is like, closer to the smaller mass than the further mass, right? So there are many points out there. I'm actually taking in keywords. So typically অনেকগুলো দেওয়ার কথা। কয়টা দেওয়া এখানে 2 marks এর জন্য। They said potential at the surface. So I mean, answer to copy করি because সবগুলোই আমাদের বুঝা দরকার। Maybe we got 2 of them, but বাকিগুলো কেন লিখিনি ওটা যে বুঝতে হবে আমাদের। So let's see if we understand all these 4 points. এই চারটা option is okay. Gravitational potential at the surface of the planet is smaller than that of the moon. Gravitational potential at the surface of the planet is smaller than that of the moon. Yeah, this is actually smaller. Kind of smaller. It's more negative value, right? So it's actually bigger. So what does that mean? It just means that the mass doesn't get enough time to fall near the moon. So, there's not enough potential to be lost. Next, also the potential gradient at the surface of the planet is smaller than that of the moon. Potential gradient at the surface of the planet is smaller than the moon. Is it though? Gradient ki kom?
It's steeper.
আমার তো মনে হচ্ছে না। Yeah. Is it? No. এখানে এই যে দেখো এখানে তো from here কি ভুল রাইট করছি এই যে এটা না বল কি করব এখানে আমি of course you'll want it to be more steep. আচ্ছা ঠিক আছে আর একটু steep করি। আচ্ছা you forced it when it wasn't very obvious. I wouldn't have written this point, okay? It's not convincing for me. Magnitude of potential varies inversely with distance from the center of the sphere. Maximum potential is nearer to the moon than the planet, right? Your point was the field strength is 0. I think what allow করার কথা আচ্ছা so that's at maximum potential. Figure 2.3 sketches the variation for field strength G at point, right? A graph টা খুব important. এটা কি গ্রাফ হবে বলতে পারো আমাকে? Yeah, it's going to be the gradient of this graph. এই গ্রাফটা gradient plot করব। So তোমাদের যদি কনফিউশন থাকে কেমনে করতে বলি, first of all এটা কি gradient, plus or minus? Plus. So I'll start with the what value? A positive value somewhere here random. ওরা কি sketch করতে বলছে না? Okay, so let's say that. তারপর হচ্ছে as you're moving তোমার gradient কি হচ্ছে কমে যাচ্ছে and this place which is closer to that than that, what is your potential or gradient? 0. So field strength 0 হবে, so it's gonna go down and around that place তোমরা box properly count করে করো. I think it's you have to be precise. I think you have to count the boxes. So এটা এদিকে এসে somewhere here is going to be 0, but then the gradient starts to become positive or negative, and like you guys say it's a higher value. So that should be it. Let me check করে দেখি if we missed any point. বলছে sketch one single curve starting with a gradient of decrease in magnitude and finishing with a gradient of increase in magnitude at d minus r. Decrease into increase in. Achha, fine. Field strength should be shown 0 near the point of maximum potential of the previous graph. We have done that. Negative field strength near one sphere, positive near the other one. Negative, positive, konta hobe eta up to you because it's subjective, right? So yeah, that is it. They didn't really say konta beshi, konta kom hobe. ঠিক আছে। Okay, তোমরা next 2 classes এর মধ্যে will be solving whatever problems you have. আমি তো আজকে একটা রিভিশন হিসেবে স্টার্ট করলাম, so তোমরা হচ্ছে solve these questions and find which one you have trouble with. Saturday and Monday we'll do this. Then we'll start thermal physics. Okay, and also I'll give you other book on Saturday. Electric fields and capacitors and magnetic fields. আচ্ছা তোমাদের কি Ramadan timing is right বলতে ভুলে গেছিলাম. Can you do classes from 1:30? 1:30, but not these days. Sunday, Tuesday, Thursday. পারবা? আচ্ছা, I haven't confirmed it yet because আরেকটা ব্যাচের সাথে কথা হবে because ওই যে স্কুল apparently অনেক স্কুল আগে বন্ধ হয়ে যাচ্ছে. হ্যাঁ বলো কি? What happened? তোমাদের স্কুলের টাইমিং দেওয়া হয়েছে? Yeah, okay, there's a potential of that. I'm not sure.